Well, okay, let's talk about cutting propagation. I'm, by the way, just here listing these Cornell red coleus cuttings. Kind of ironic because we talked about how coleus can root easily by just sticking a cutting in a glass of water. At any rate, cutting propagation is similar to propagation by layering, except that we start out by removing the cutting, taking it off the original plant. And that creates a problem. Because unlike the layered plant that has its original root system as a source of water and nutrients, the cutting no longer has a root system. And that puts it at a distinct disadvantage in terms of primarily desiccating, drying out, and dying before rooting ever occurs. So one of the most important things in cutting propagation is environmental management so that we prevent desiccation. And we do that by managing three different environmental factors. These are light, temperature, and relative humidity. Now, one of the factors that influences water loss from the cutting is light and its effect on the temperature of the leaf. In bright light, a leaf is likely to be several degrees warmer than the surrounding air. And when there is a temperature difference between the leaf and the surrounding air, that increases the transpirational pool, if you will. And so it is critical to keep the light levels relatively low. And to do that, we use shade cloth, such as the shade we have here to create the right lighting for this shot. Shade can be very critical. Another way to minimize transpiration is to keep the humidity of the air surrounding the cutting as high as possible. So we can do a number of things to keep the atmospheric relative humidity high. Now we can divide cutting propagation along the lines of the intensity of environmental management. At the bottom level, we have those species that are very easy to root. So here I have some willow shoots that I cut off earlier this afternoon, and these are hardwood cuttings. This is dormant hardwood cuttings during the wintertime. They defoliated in the fall. And willow is so easy to root that we can just cut it into pieces, even long, thick pieces like we used last week. And as long as these don't have leaves, they're not going to transpire. They're not going to lose very much moisture at all. And since they are easy to root, they will root rapidly, and you can succeed in hardwood cutting propagation. So here, for example, let's just stick these. Let's make believe this pot was a field situation with soil. And we'll just take some sort of a tool and create a furrow and stick these cuttings very deep. Grape hardwood cuttings, rose hardwood cuttings are propagated this way to be used as rootstocks for grafting. Not willow so much as the other two. Notice I'm putting the cuttings very deep at a slight angle so that as much as 2/3 of the cutting is below ground. That too minimizes water loss even from the stem surface. And this could be outside, and as long as there was adequate soil moisture, these willow cuttings or grape cuttings or rose cuttings for that matter, other species too, would root rapidly. Now the next level of environmental management is for cuttings that are what I call moderately difficult to root. That would include things like landscape shrubs like forsythia, privet, things like that. And these are generally taken as leafy cuttings, not hardwood cuttings, because the leaves and the actively growing shoots are actually necessary to promote the rooting. Photosynthesis is involved in creating sugars that are used for metabolism. And furthermore, the growing shoot tips are producing the plant hormone indole acetic acid, which is being translocated to the base of the cutting, and down there it stimulates rooting. So in the case of these leafy cuttings that are moderately difficult to root, we can manage them by keeping the relative humidity high. And so I'll move this hardwood cutting off the table and bring up here one of the simplest ways to manage environmental relative humidity. Polyethylene has been a very important tool for horticulturists in the last half century or so. you can see is a flat of cuttings. We use a wire frame to keep the plastic up off the cutting surface itself. And you probably would realize that if the sun is shining on the plastic bag, it's going to get very hot in there, the so-called greenhouse effect. So when you're using polyethylene to raise the humidity, it's very important that you keep the cuttings shaded. So here we have some forsythia cuttings that were stuck not long ago, and quite a few of them are well rooted. Here, for example, is a well-rooted forsythia cutting. Now let's consider even more extreme environmental control. This would apply to cuttings taken in the late spring or early summer as softwood cuttings, which are very subject to drying out very rapidly. So it's not sufficient just to increase the atmospheric relative humidity. Here we have to be very concerned about the leaf temperature, and one of the best ways to do that is to get the leaf wet periodically through irrigation, or as we call it in propagation, intermittent mist. This is great fun, particularly on a hot summer day. Now what we're doing here is spraying the cuttings, and sure, that does increase the humidity, but even more importantly, what it does is decrease the leaf temperature. And as I said before, if there's a difference in leaf temperature, hotter leaves in the surrounding air, that will promote transpiration. If you bring that leaf temperature down by misting it, then there will be less transpirational driving force and less water loss from the cutting. So mist propagation then is typically used for the more difficult to root species that are propagated from softwood cuttings. Let me show you how we actually stick the cuttings under an intermittent mist system. Let's start with some hibiscus cuttings that I have in the bag here. These are soft to semi-hardwood cuttings. And I've collected the shoot, and you notice that it was in a plastic bag. That's an important facet of moisture management. I wetted the cutting before I put it in the plastic bag. The humidity in there is very high. When I'm ready to take it out, I have to be careful about moisture loss. Now I'll make a cutting here. Probably start off by taking off the tip. That's not mandatory. Come down a couple of nodes and cut there. And this is almost ready as a cutting. I'll strip off the basal leaf. And in a species like this that has fairly large leaves, the greater the leaf surface, the more transpiration. So you can, with many species, reduce the leaf surface area just by cutting it in half. Now, all we have left to do is to treat this cutting with a root-promoting hormone. I have some of that back here. And hopefully the mist won't come on while I'm demonstrating this. But basically, I mentioned before that an actively growing shoot tip is producing a hormone called indole acetic acid. And that hormone has many different physiological effects on plants, one of which is to stimulate adventitious root formation. And this has been exploited horticulturally. We have a number of synthetic auxins that are used in commercial preparations like this. And we would typically take a cutting like this, dip it in water, and then just dust the base of it with the rooting hormone, tapping off the excess. And I would do that with quite a few cuttings. I happen to have some additional ones here. Okay, with these additional cuttings, I'm just about ready to go. I take a tool like a large knife or a spatula like this and use it to create a furrow using this wooden board as a guide. Just loosen up the rooting medium here. This happens to be perlite. And I can take the cuttings and stick them at uniform intervals. The stick is actually marked off every inch. I'll stick these cuttings about 2 inches apart in a row. This way you get them nice and straight, nice and uniform. Then I can pull that board out, place it on the other side, and tamp it in. Sometimes this is done with a hammer. That presses the media down close against the base of the cutting. Then we would set the timer on the mist control system to come on anywhere from once every 2 minutes to as long as once every 20 minutes. That would depend on the environmental conditions on any given day. Today is a bright sunny day, so we would probably set the mist interval to come on every 2 to 4 minutes. If it were a cool, cloudy day, such as prevails in Ithaca through most of the winter, we might set it to come on every 10 or 20 minutes. And this is a choice that the propagator makes. It's ever so important to be aware of the environment that the cuttings are exposed to get the best rooting possible.